Hello friends, welcome to Ccna video series lecture number 5. Topic of this lecture is IP version 4 subnetting and VLSN. It is recommended to watch lecture number 3 and 4 before watching this video. If you have not watched lecture number 4, click the link in the video description to understand basics of IP version 4 classes and subnetting. Because this is a fast-paced lecture and I am not going to explain the concepts which I have fully covered in my previous lecture. So let's start. Before subnetting class A and B addresses, we will go through a few more examples of class C subnetting from /27 to /30. The default subnet mask of class C network is 255.255.255.0 and its CIDR value is /24, which means that there are 24 bits in the network segment. Let's expand 8 host bits with their spot values. For subnetting, you will have to borrow bits from the host segment. Let's borrow 3 bits from the host segment for the subnetwork, so the new CIDR value will be /27, as now we have 24 plus 3, that will be equal to 27 bits for the network segment. To understand subnetting, carefully note down the following steps. Step number 1, our new subnet mask will be 255.255.255.224, as the spot values of borrowed bits are 128 plus 64 plus 32, that will be equal to 224. Step number 2, the number of subnets will be 2 raised to power 3 because we have borrowed 3 bits and that will be equal to 8. So we will get 8 subnets. Step number 3, number of hosts per subnet will be equal to 2 raised to power 5 because there are 5 bits left in the host segment, and that will be equal to 32. But remember, we had subtracted 2 from possible host values, one for the subnetwork ID and other for the broadcast address. So our valid hosts per subnet will be 32 minus 2 equals to 30. Step number 4 is to determine the block size of the subnetwork, that will be 256 minus 224 equals to 32. Note that the value of 224 is the value of last octet of new subnet mask. Based on the values we got, let's generate our table of subnetting in Excel. The first subnetwork ID will be 0. Then we will keep adding the block size of 32 in the previous subnet ID until we get 256. We will start from 0, then by adding 32 in 0 and expanding the formula until we get 256. We will get 0, 32, 64, 96, 128, 160, 192, 224 and 256 as the subnetwork IDs. But we will not include 256 as our subnet ID because the maximum value of 8 bits is 255. Now let's find broadcast address of each subnetwork. To find broadcast address, add the spot values of remaining 5 bits, which will be 31. Now add 31 in each subnet ID and expand the formula to get broadcast address of each subnet. Note that the broadcast address is 1 less than the next subnet ID. To find the first valid host, add 1 in each subnet ID. So first valid host of each subnet ID will be 1, 33, 65, 97, 129, 161, 193 and 225 respectively. To find last valid host, subtract 1 from broadcast address of each subnet. So by applying the formula and expanding it, we get 30, 62, 94, 126, 158, 190, 222 and 254 as the last valid host of each subnet. Hence, we have completed subnetting up to /27. Now let's start /28, /29 and /30. For /28, we will have to borrow 4 bits. Now subnet mask will be 255.255.255.240, and by following the procedures in previous example, we will get subnetting table of /28. For /29, we will have to borrow 5 bits. New subnet mask will be 255.255.255.248, and by following the procedures in previous example, we will get subnetting table of /29. For /30, we will have to borrow 6 bits. New subnet mask will be 255.255.255.252, and by following the procedures in the previous example, we will get subnetting table of /30. In the next video, we will subnet class A and B networks. Thanks for watching. If you like the video, please subscribe to my channel and press the bell icon to get regular updates about upcoming educational videos. Thanks.